In this video, I want to use retention indexes to increase my confidence when doing unknown data analysis. First, to define a retention index. While a retention index relates to a retention time, it's defined by what two straight-chain hydrocarbons it comes out between. In this example in purple, I've ran a retention index standard that starts with C7 or heptane and ends at C30 triocontane. C10, for example, starting at C7, which would be 700, 800, 900, 1000, C10 or decane should be defined with a retention index of 1000 because it has 10 carbons. If I'm to follow this logic backwards from the end, and I want to identify this peak in red, well, I know that triocontane, C30, has a retention index of 3000, 29, 2800, 2700. So whatever the correct answer ends up being for this small red peak should have slightly higher than a 2700 retention index. Let's go ahead and identify it and then check with NIST. With this identification and a fairly high score, I likely already have the right answer, but to confirm it using retention indexes, we're going to have to look that chemical up in NIST. When looking up the standard nonpolar or the semi-standard nonpolar, depending on your column type, it does indeed have slightly higher than a C27 or 2700 retention index. While overlaying a retention index standard can be useful, I've also built a tool to estimate retention indexes based on retention time. So with a retention time of 17.1, using my Excel spreadsheet, I've plotted all of my different retention indexes versus their specific retention times. I have a line of best fit going through that curve, and then I've used that line of best fit to estimate retention indexes up here in the top right. My retention time was 17.1 minutes. And when I enter that in, it gives me about 27:38 for my expected retention index, which happened to be very close to the true answer's retention index, confirming and increasing our confidence that it was the right answer. I hope this helps.